Hey, this is Yogeshkumar Rathod. Very few amongst the highest degrees achievers in the world. Welcome you all to my lecture on heat transfer. Heat transfer is that branch of engineering the subject of heat transfer is concerned with the determination at the rate at which energy is transferred by virtue of temperature difference between two bodies. The subject of heat transfer is prerequisite to any branch of thermal engineering. There are basically three laws of conduction, convection, and radiation. According to second law of thermodynamics, so long as there is difference in temperature, motive power can be produced, work can be done. The Planck statement, Kelvin Planck statement. And another statement is also Clausius body. Heat cannot flow from cooler body to hotter body. Some work must be expended to achieve this. This is Clausius statement. Conduction is the process of heat transfer in the same medium. The particles are almost stationary. Heat flows from one particle of body to another particle of the body. The governing equation is Fourier's law of conduction. Rate of heat transfer is Q is equal to minus Ka dt by dx. K is the thermal conductivity in this case. E is with which heat flows, it determines the example of heat conduction is heat transfer in metal rod. Heat transfer in composite walls, composite cylinders, composite spheres are the example of heat transfer in advanced level courses. Calculation has to be done by conduction, convection, combined numerical and convection, radiation, conduction, numerical, combined numericals. Convection. Convection is the process of heat transfer by convection current between two different mediums. Example of convection is heat transfer in the case of gases and liquids. Heat transfer by convection current. The governing equations. Q is equal to rate of heat transfer is equal to HA delta T. H is the convective heat transfer coefficient. There are various types of convections: natural convection and forced convection. Natural convection is one which occurs naturally. Density decreases and convection takes place. Is the natural convection. Forced convection is one which is done by use of blower or compressor. It's called forced convection. The third and final heat transfer process is thermal radiation. Thermal radiation is the process of transfer of heat from hot body to cold body. Example of thermal radiation is heat of sun reaches to us by the process of thermal radiation. Governing equation of radiation is rate of heat transfer. Q is equal to sigma A T to the power 4, where sigma is Stefan Boltzmann's constant, which is given by 5.67 into 10 to the power minus 8 watt per meter square Kelvin to the power 4. There is always problems of combination of conduction, convection and radiation in advanced level heat transfer courses. Emissive power is of importance. One should know shape factor, dimensional analysis is also one should be aware of. Calculation of emissivity Heat exchangers is another aspect. Parallel flow heat exchangers, cross flow heat exchangers, counter flow heat exchangers. One should be aware of derivations, long derivation. One should be aware of using it. Parallel flow is if both the fluid flows parallel to one another, is parallel flow heat exchanger. Counter flow is one which heat flows counter to each other. Cross flow heat flows perpendicular to each other. I'll give you more information. You can like it, share it, and subscribe it. My YouTube channel is Tech Yogeshkumar. I'll give you more information later. Thanking you.